In this video and live telecast, I'll be talking about circle geometry. When we are talking about circle geometry is a very interesting topic. And in this video, I will teach you everything. There are 11 theorems. I will teach you everything you need to know in terms of circle geometry. Because circle geometry is very, very important. And without it, there is no how. So now, without circle geometry, there is no how you can understand mathematics. So let's take the theorem one after the other. So let's go to the first theorem. Now, the first theorem says the angle that subtends at the center is twice the angle that subtends at the circumference. That's the first theorem. The angle that subtends at the center is twice the angle that subtends at the circumference. Now, let me explain that and let's prove it together so that we can understand it better. Now, let's take this for example. Let's say we have a circle like this. We have a circle and this is the center. Now, looking at the center over there, we have an angle that is subtended at the center here. Let me say it comes from A, B, and is subtended at the center. And we have another angle that is subtended at the circumference. This is the one that is subtended at the circumference. Now, the twice of this angle, twice of this is always equal to this. It means anytime this one is x, for example, this one will be 2x. How do we arrive at that? Or how do we get that? Very simple. Let's try to make this one to be like this. Now, if I call this C, if you look at this very well, this is a triangle. This is also another triangle. And this triangle is an isosceles triangle because this is radius from here to here. From here to here is also radius. So we can rightly say that, looking at it in that way, you can say that this place to this place is also the same thing as here to here. So it means this is an isosceles triangle. So if you have to carve it out, there's a particular thing we always talk about in terms of isosceles triangle. What do we always say when it comes to isosceles triangle? We always say that when we have a triangle here, generally, if this is angle A, let me call it X. Let me call this one Y. What is outside there will be X plus Y. That is the addition of this angle will be equal to this angle outside. So it means the angle that subtends, so the exterior angle of a triangle, the exterior angle, this is called the exterior angle. The exterior angle. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. And when we want to do this, when you add it together, you have to get this. Because if you have to verify and check that, it's not something so hard. For example, if you have 48 here, and here, for example, you have 62. Now, normally to get this, I told you that this one is the addition of this to this. So let's check it. 62 plus 48, that will be 110. So this place should be 110, which is 62 plus 48, as the case may be there. So that will be 110 degrees. Let's verify. Now, adding this together, because the sum of this and this and this should be 180. So it means adding this together, which is 110, and you say 180 minus 110 degrees. We all know what that will give to us. If you take 180 minus, that will be 70. So it means this place will be 70. So, and this is the angle on a straight line. So you can see the addition of this and this is 180. So this has validated that sum of this and this will give us this, which is the exterior angle. And that's one of the rules in the triangle. Please, if you are watching this video, make sure you like it, please. Make sure you like this video. If you are watching it, please like the video. So let's go on. That means if we call from here to here, if you call it x, since it's an isosceles triangle, remember that when you have an isosceles triangle, the base angles must be equal. So when this is x, this must also be x. Now, this plus this being the what? The interior angles. There are some will give us the exterior angle, which is this for this triangle. So this should be 2, it should be x plus x, and that should be 2x over there. So if we call this one y, this is y, this is also y. So y plus y will actually give us 2y. Let's now look at it perfectly. It means the two of them, as we have it here, 2x plus 2y. Okay, that will be 2 into x plus y. So it means the addition of this will give us 2 into x plus y. This one also, when you add it together, this will be x plus y. So we have buttressed the point that this is twice of this. So any circle at all, when you have a circle, any circle where the angle subtend at the center and you have another angle subtend at the circumference, let's say it is like this. Look at this. So the two angles, this angle and this angle, they are of the same father and the same mother. A and B, let's put that in mind. They are of the same father and the same mother. And this one is at the center, this is at the circumference. So it means if this one is x, for example, this should be 2x. Okay, so another angle can come this way. So for sure this one will also be x because it's originated from A and B. That is line A and from line B. Another one can go up this way. It will still be x. So another rules in circle geometry is this. The first rule is what I've explained now. The first rule says the angle that subtend at the center is twice the angle that subtend at the circumference. The one that subtend at the center is twice the one that subtend at the circumference. So let's get that very correctly. Now, this angle and this angle and this angle are the same now. What do we call this? This is another theorem. That's theorem number 2. I've explained number 1 now. So theorem number 2 says angle at the same segment are always the same. Okay, angle that subtend at the same segment are always the same because I can put a line here. If I put a line over here, it means this is our minor segment and this is our major segment. What is up here is our major segment. So this angle and angle, they are of the same segment, but mind you, they must originate from the same place. So that's what we have over there. So let's go back to the textbook. Now, looking at this over here now, what do we have there? We said theorem 1, the angle which an arc of a circle subtend at the center is twice that which it subtend at any point on the remaining part of the circumference, and that's what happens here. So what I've explained now is what is being done here. Different circle over there. So the theorem 2 says angles in the same segment of a circle are equal. This and this are the same segment. If you look at it very well, this angle xi originated from A and B. Now, if you look at A, from A it goes, from B it goes, and they met here. This also originated from A and B. So if you look at it very well, it means this and this are angle at the same segment. And this is the angle on the center, which is twice those that are on the same segment. So that's the second theorem, which I believe is very simple and orderly. So going to the third theorem now. The angle in semicircle is 90. Any angle on the semicircle will give you 90. So let me buttress that and explain further. Now, looking at this, when you have angle at a semicircle, if you remembered, this is the center. If you remember, I just told you that angle that subtend at the center is twice. Angle that subtend at the center is twice those ones that subtend at the circumference. So that's what we are doing here also. So it means when you have a straight line will cut the circle into two. But mind you, there's an angle here, which is 180 degrees. This one is also subtended at the center. You can say it starts from A and B. So it means the angle that now subtended at the circumference will now be angle 90, which is half, which means this one will be twice of this. Okay, which means for this one to be 180, this one will be 90. No matter where you form the angle, it can be formed like this, it will still be 90. It can be formed here, it will still be 90. So that is our theorem 3. That is theorem 3. So theorem 3 says the angle in a semicircle is 90 degrees. That's theorem 3 on circle geometry. So we are getting there gradually. Now, theorem 4. It says angles in opposite segments are supplementary. Okay? Opposite angles of a cyclic quadrilateral. Let's look at this very well. Quadrilateral, it has 4 sides. 1, 2, 3, 4. There are 4 sides to it. Okay? And because it has 4 sides, and the 4 sides are touching the circumference of the circle, so we call it cyclic quadrilateral. Now, being a cyclic quadrilateral, the opposite sides are supplementary. What do you understand by supplementary? You see now, supplementary means x plus y. This x plus y will give us 180. And also p plus q plus p, or p plus q will give us 180. Let me quickly explain what we mean by supplementary and complementary. Now, supplementary angles. Let me say complementary first. Complementary angles. Okay? They are the angles that adds up to give us 90 degrees. So when any angle gives us 90 degrees, it's called complementary. And when any angle, when you say supplementary, so it means the angles that are to give us 180 degrees, they are called supplementary. So that's the difference between that. So let's go on now. So it means for any reason, theorem 4 says any cyclic quadrilateral, when you have the opposite side, it will give us 180, which is the meaning of the supplementary. So let's move over to theorem 5. Theorem 5, we said the exterior angle of a cyclic quadrilateral, we are still referring to cyclic quadrilateral, is equal to the interior opposite angle. This one can be proven. It's very, very simple. Since this and this will give us 180, it means you can get this also. Let me give an example now. If you have a circle and you have a cyclic quadrilateral in it, okay, and you have an angle here, you have another angle here, but you have the exterior angle also here. Now, this and this must add to give us 180, as we have said the other time. So it means if this one is 80, for example, now, this one must be 100 to give us 180. At the same time, sum of angles in a straight line, mind you, must be 180. So it means taking this away from 180, this must be 80. You can now see that this and this will always be the same. So that's what theorem 5 is telling us, that the exterior angle of a cyclic quadrilateral is equal to the interior, which is equal to the opposite. Okay, so that's what I've explained there, and it's very, very simple. So we'll be moving over to theorem 6. So theorem 6, what does it say? Theorem 6 says, and the tangent is perpendicular to the radius at the point of contact. Let's look at this. Any circle at all, and the radius of any circle will always be perpendicular. Perpendicular means it's forming angle 90. to any tangent. Tangent is a line that is touching the circumference outside. Tangent is a line that is touching the circumference outside. So it means any circle at all. It means any circle. Let's take, for example, any circle to the center, and you're having any line. The line can come like this, touch the circumference. Okay? It can come any other way, touch the circumference. It can come any other way, touch the circumference. So from the circumference at any point in time, which is, take the radius, it must be 90. This must also be 90. Take the radius also here, it must be 90. This must also be 90. Take the radius from here, it must be 90. This must also be 90. So that's another theorem, which is theorem 6. Mind you, all this theorem will be used whenever we are doing our calculation. Now, theorem 7. The angle between a tangent to a circle and a chord, that this is a tangent to a circle and this is a chord, through the point of contact, that is through the point of contact here, is equal to the angle in the alternate segment. Now, look at this and this. They are alternate segments to each other. This is a segment because it's touching the circumference, and this is alternate to it in terms of the tangent. So this can also be proven. Let me try and prove it, and we'll see how it proves. Now, let's take, for example, if we have a circle, let's take a circle, for example, now. This is a circle. You must not forget that we say whenever you have a tangent to a circle, it must form angle 90. Okay? Let's say that's an angle 90. Now, taking this is also a chord and also a diameter. Taking this up like this, remember that this place will give us 180 degrees. And any angle of a semicircle is always 90. It will be half of this. Because this one subtended at the center, this one subtended at the circumference. And anything that's subtended at the center is twice that of the circumference. So can you see that this and this are the same? Just to buttress the point. So it means any line or any chord to a tangent, the angle outside, okay, will be the same with the alternate angle. So also any angle that is here, if it is B, it will be the same thing here. Let's say this is A, and we call this C. So it means A plus C plus B will be 180. Also A plus B plus C will also be 180, which is sums of angles in a triangle. That's just to buttress it and make you understand it. So theorem 7 again says the angle between a tangent to a circle, this is it, and a chord through the same point of contact is equal to the angle in the alternate segment. The same thing here. This and this are the same. So that's theorem 7. So let's move over to theorem 8. In the theorem 8, we say two chords, PT, this is a chord. But when it is being extended, or we say it is being produced outside the circle, it becomes a secant. A secant. But this is a chord called PT, and RS of a circle intersect outside or inside a circle at a point at a point Q. This is a point Q. What is the formula that brings it together? It's very simple. Now, we see this as a line that is being broken. This is our point of contact for both of them, and is the most important point. So what do? We are to say PQ, line PQ times line TQ. We say line PQ times line TQ will be equal to line RQ times line SQ. Let's check it here. So it means line PQ times QT is equal to, you can see, PQ times TQ or QT, as the case may be. It will be equal to line QR or RQ is still the same thing, multiplied by SQ, or we call it QS. It's still the same thing. So that rules must be studied properly. Even if it is inside, no matter the less, they joint here. Okay, so the first thing we have to do, as we have followed this, P to where they join, and from the circumference to where they join. So the same thing here. So P Q and the P T multiply like that. So that's the theorem 8. So let's move over to theorem 9. Now, in theorem 9, we said two tangents SR. This is a tangent now. This is another tangent because they are touching the circumference of the circle and they are meeting at a point. Two tangents SR and SK to a circle with center O are equal in length. Now, this and this are equal in length. So therefore, everything that is inside will be equal. This angle to this angle are equal. This angle to this angle are equal. But what is that formula that we can use to solve and make our theorem to work? Now, you can see this SR. Normally, it should be SR squared is equal to SK squared. But the square will cancel at both sides. So it means SR is equal to SK. That is SR is equal to SK. So also look at this angle. This angle will be SOR. This angle SOR is the same thing as SOK. Okay, so angle R and K are all the same. They are 90 because this is the tangent and this is the radius, and we have said that in one of our theorems. So they are equal to what? They are equal to 90. That's theorem 9. So let's move over to theorem 10. Now, in theorem 10, what we have there is that if QK is a secant. Now, look at K, R, Q. QK. If QK is a secant, and look at this one, QS is a tangent. So if QK is a secant and QS is a tangent, okay, to a circle, then SQ squared, this one you have to square it because it's the only one. Is not broken into two. So SQ squared is equal to QK times QR, or we say QR times QK. So we can see as we have it there. So now this is the formula you will use whenever you see anything like this. Okay, so it means the secant. It means the secant from here to here, because this is the chord. And it produces that it becomes the secant. The secant from here to here, we divide it into two, which is this and this. You multiply, but the tangent is always remaining like that. So let's go to theorem 11. In theorem 11, you have two circles. Theorem 11, you have two circles. One big circle and the other small circle. So for that circle, I would like not to use small r and small r. Now here, to buttress the theorem, we'll be using the knowledge of similar angles. Similar angles. Okay, so it means when we have a circle, we have one circle, big circle like that, and we have another small circle, and there is center here. So from one center to the another center, a line is being drawn. So just like this, a line is being drawn from one center to another center. Okay? And when we have that, it means to our circumference, we have something, because this is our radius. And there is a line which serves as the tangent, crossing across the second circle here, which serves as the tangent. And as we have it there, the tangent to the radius is always angle 90, to the radius is always angle 90. Okay, so let's call this the big R, and we have K. Let's call this the small r. Okay, so here we have T, K, we have W here, and you have O here. Looking at this, there are two triangles in this place. In the similar shapes, we always go for two triangles. For example, similar shape of a two triangles, you have big one and you have a smaller one. For the big one, which is this, it will be KS. Let this place be S. This will be KS. So it means from here to here will be KS. KS. Here is O. So we have O over here. This one will be KW here. That's K to W. And here will be T. So we have T. Now, this place will be the big R and this is the small r. When we are to solve similar shapes, the bigger one over the smaller one or the smaller over the bigger one, you follow it to the letter. So how do you go about that? So let's take for example, let's say we are starting with the smaller one. So it means KT divided by KS, because they have the same similar side, divided by KS. So is equal to, so you can put a line or we don't put it, nevertheless, it doesn't matter. Is equal to SO. Are we starting with the small one? No, we are starting with the small one here. So it's equal to TW. So that should be TW, which is a small r. So let me put is equal to small r divided by big R. And that can be equal to KW divided by KO. So any value given, we slot it in. We use that to solve our problems. So let's now use that to check what we have here. Now, looking at this now, this is the big triangle, this is the small triangle. It's followed the same way. So this, I will take it as the big R, and this as the small r. So let me take this as the big R. Okay? So now, SK, that's why we have our SK. They are starting with the big one. SK divided by this and this, KT or TK, is equal to OK, which is the hypotenuse here, divided by WK, is also the hypotenuse of the small one. You see now, is equal to now the big R divided by the small r. So this is the formula we always use for the theorem, which is the second, which is the number 11 theorem. So I strongly believe that from theorem 1 to theorem 11, we understood it perfectly with my explanation, because I took my time for this live video to explain to you thoroughly, so that there will be a good understanding of what circuit geometry is. So that's everything about circuit geometry, and I believe you understand it perfectly well. So if you have watched or you are watching this video, to encourage us to do more of this, in this channel I always do physics, chemistry, mathematics. I do a lot of questions. Please encourage us by liking this video, like it, and let us comment in the section below. So if there are other ways that you think we can do it, try to comment in the section. Or if there is a problem that you want me to solve and explain to you in other videos I will be making, please let us signify and let us comment in this comment section below. So now, in more videos, I will be solving some questions related to circuit geometry. Thank you and God bless you. Bye-bye. See you in another video. God bless you. So you can share this video with people, because I'm going to upload it. I will upload it so you can share with people. Okay, somebody is asking me which time did I start the live chat, chat. I always do live chat 9 p.m. So now subsequently I'll be doing it every day now. every day. So I will let you know, maybe it will be 8 or 9, but presently I'm doing it at 9 p.m. every Wednesdays and Saturday. But I will likely start to be doing it every day, because I will also be covering a topic in chemistry, physics, and probably mathematics and further maths from secondary school, from class 11, class 12, even class 10 to the university level. I'll be covering that. So that's what it's all about. So I think I don't have any much questions to answer again. So see you by Wednesday, by God's grace, and I might also do before Wednesday, but I will let you people know if I will be doing any other live videos. Thank you and God bless. See you later. Thank you. God bless you.